everybody, kia ora koutou. Welcome, I guess, although I'm coming to you, so maybe I should be welcoming myself to your place. Thanks for coming. Yeah, my title is Who's Doing the Maths, the tech or the students, tech or the learner. I've got a little starter screen up there that we will come back to. So yeah, I'm talking about tech today, and Katrina Shearer was her old name, she's renamed since, has these awesome tweets, and a tweet is technological, but what she does is she draws these hand-drawn diagrams, and so it's quite a low-tech thing put in a tech place. So that's just going to sit on the side for a little bit as I talk a little bit about where we're going. Hopefully you guys can all hear me all good. So Rachel, Alan, just give me a thumbs up if my voice is okay. Okay, cool. All right, so what I'm going to do today is just talk quickly about me and my learning, just so you know the context, I guess. And then we're going to try to get our head around understanding the role of tech in maths, some ways of thinking about tech in maths, I guess some models and some categorizations. We will mention some issues and some benefits, and I'm going to try to involve you guys in a little bit of that. So there'll be some links that come up through the chat at times that I'd like you to put your thoughts into. And then we'll have a look at three kind of main tools, and hopefully I've timed this out well enough that we can spend enough time on all of those things. Okay, so me and my school. I'm stored on the screen, sorry. Okay, I'll talk about it without the slide. I'm from Western Springs College, Ngāpuna o Waiora. We are a co-ed school, we're a non-uniform school, we're a very modern school, I suppose. We also have two parts to our school. We've got the English speaking part, and we deliver the curriculum in English, and then we have our Te Reo speaking side of the school, which is better known as Ngāpuna o Waiora. We have been BYOD for a number of years. Many schools are in that place now, but some may not be completely BYOD, so I guess that's our context, it might not be yours. And in our school, digital tech, which is this thing that's come up in the last couple of years, we're trying to teach it within the core subjects rather than having it devoted. So that was the change that came into the curriculum. I think last year it was supposed to be implemented, but last year was a funny year, right? So there's a picture of what our learning environments are. We're ILE, Innovative Learning Environment School now, the last year and a half, last 2 years really. I'm one of the AMA execs. I put that picture of me graduating. So I graduated a couple of weeks ago with a Master of Professional Studies in Maths Education. And I guess I don't like to gloat, but the reason I wrote that is because my dissertation was about this kind of stuff. It was about digital tools, and I looked at it in both the physical classroom and also in the virtual classroom, because that was a big thing last year. We were all learning about that. Today I'm only going to focus on sort of the in-class stuff more rather than trying to deliver lessons online or anything like that. Okay, so let's get into it. Here's a question. How would you do the following? What is 2 and a 5th of 20? Let's take a little bit of think time there. So I've got some ways that people might do it to come up on the screen. So there's that one, basically pen and paper. Maybe you wouldn't use that particular method. You might draw diagrams. You might have another way of doing it, but you're using the pen and paper to get you to your answer. You might do it that way. Okay, nice and quick. Or even these days, you might do it this way. What should be coming up is a Wolfram Alpha page that will solve something like this. I think with the calculator, what we've always told ourselves is, at least, yeah, I'm struggling with my connection a little bit, sorry, is that the students were still having to interpret it and mathematize it so that they could use the calculator to get to an answer. That's becoming less needed these days, as you can see from that web page, that you can basically type in the words for this problem into Wolfram Alpha, and it will say, well, here's the way that we think we would turn it into maths, and here's the answer, and here's a picture of it, and here's it written in words, and it can do all of those things for you. The one I haven't put on here is PhotoMath, which is this ability to just take your camera, camera on your phone, and hover over some maths on a page, and it will know what to do with it and give you an answer straight away. So the tech could well be doing more of the maths than what we ever thought it was going to do. So I guess that's something that I want us to think a little bit about, and how bad a thing that might be. So a couple of people who have some thoughts on this, Keith Devlin and Conrad Wolfram. So Keith Devlin is a very high-level mathematician. He's very thoughtful about maths education as well, although that's, I guess, not really his field. He does write about it. There is, you may have seen this, there is a presentation he does about what tools mathematicians actually use. And he, being a practicing mathematician and someone who works with a lot of mathematicians, is pretty well versed in this stuff. And so that that left picture over there is what he's come up with as go-tos when he's doing some maths. And it's an order. So Google is the first place he goes when he has to do some maths to understand the problem perhaps, or similar to Wikipedia, to sort of really understand the mechanics of what he's dealing with before he can get anywhere. You see that communicating through email and things like that are really high up there. You've got spreadsheets and mathematical applications in sort of that middle section. And then right towards the end, he might have an actual calculator come out, and he will do some stuff on pen and paper. So yeah, the hierarchy of tools is really changing. Wolfram is involved in education, but he is also now the CEO of the other Wolfram products like Mathematica and things like that. So that's an interesting quote. I guess I'll read it. Actually, mathematics is the wrong word for much of what is taught in schools. Rather, students learn to calculate. This is an obsolete skill since almost all calculation is done by computers these days, except that is in educational maths where almost all of it is done by hand. So really, he's asking us to take our kids away from doing so much calculation, letting them use some technology to do that calculation. But then I guess the question is, well, are our kids doing as much maths as what they used to if the technology has taken a role in this? If you do find time at some stage, that website is a curriculum that he has designed where computers play a big role in the mathematics that students are learning to do. So there's a whole model about how you do maths with computers and what the role of the human is in that, I suppose. Okay, so here is a question, just another think one, you don't have to respond. Which understanding is natural for you when you talk about a circle? There may not be the perfect one there, but I would like you to think about which one would fit me best. Okay, so there are definitions of circles, but we all have our own sort of idea about what they are, or something that comes to mind. And what I would say is that technology will, the way that you create a circle will make you think about it in a certain way. So when I first created circles, I drew around cans, or I used a compass. I set a radius on my compass and started mapping it around. So for me, when I thought about circles initially, that's what it was. It was this point that was getting rotated around a center. But in other technologies, that's not how you make a circle. So you might start to conceive of circles in a different way. So technology actually influences us in the way that we conceive things. It's not just this thing that we use, that we are users of. Maybe it is actually influencing the way we're thinking a bit more. So that's why I use the term bias, that we can be biased to think in certain ways because of the technologies that we use. Now, we can easily say that a compass is a technology. It's not a digital technology, but it is a technology. In fact, we could go as far as saying language is a technology, and pen and paper is a technology. And I think that's fine. They are tools that we use. I guess today's focus is on digital technologies, though. There is a term that you see sometimes called coaction. So this is the idea that the maths that I'm doing, it can be used in other contexts too, but the maths that I'm doing is made up of what I'm doing, but also of the tools that I'm using to do it. Without those tools, maybe it wouldn't have happened. So the famous physicist mathematician Richard Feynman has an interesting little story about this. A journalist, I think, was asking about his ability to do maths and suggesting that the pen and paper was a record of what was going on in his head. And Richard was quite argumentative about this in saying that no, that pen and paper was integral to what I did. Me and that pen and paper were doing the maths together, and it wasn't just me. So for someone who was considered extremely smart, he wasn't arrogant enough to think that that was just stuff that was coming out of his head onto the piece of paper. Another term that I will talk about a little bit and comes up in literature is instrumentation. And this comes from the analogy here is music. When you create music, you do it with an instrument. And the person, you could say that the person's creating the music, but we start to say that the person and the instrument are creating the music. And without the instrument, the music, wouldn't have happened, but really couldn't have been conceived of in the same way. The instrument has sort of made the user able to think of music in a certain way. And with digital tools, we start to get to that as well. That when we start to use digital tools, we start to do maths, and it affects the kinds of maths that we might be doing a little bit. We learn particular skills. So in terms of music, you might learn particular things you need to do to the instrument to get sounds, but that instrument will rub off you and make you think in certain ways too. So the fancy word of mental schema comes up in that. So yeah, instrumentation is, I guess, skillful is not a great word for it, but becoming skillful in the use of, we'll say, digital technology today, or digital tool today, so that you can do maths and solve problems, I guess, at the end of the day. Okay, so Drivers is one of these people who talks about instrumentation a lot, and this is also his idea about how we can think about technology and maths, identical functions. So we see that he's split it up into, well, technology can actually do maths, a calculator can be used to do maths, but technology can also be used to learn maths. And he split that up into two types of maths, that practicing of skills, which is still a pretty valued thing in maths education, that kids need to practice things, but also to developing concepts. Technology can play a role in kids practicing and in also developing their concepts. So I put that up because I'll revisit that a little bit as I talk about a few bits of technology that do come up. Okay, this is maybe an unanswerable question. Doing maths with tech, how much of it should our students be doing that way, and how much should be tech-free, I guess is what I'm asking. In the real world, people use the right tool. They use the most efficient tool, the most accurate tool that they can get their hands on, that they have. And maybe based on my previous slides, to have a tool, you kind of have to have some experience with it to know what it can do. But this is fine when that's there. When you want a pragmatic outcome, when you want a good result, then you should use the best tool that you can get your hands on. And that's tricky in our classrooms, because we want to often give them some conceptual learning and not just the quickest way of doing something. We even do that when we're doing non-tech lessons, that we want them to understand the kind of concept behind something rather than just knowing a quick method for doing it, which might be to like a trick to completing something quite fast. Tricks are great, but the concept is often what we're trying to develop with them. There is a term called outsourcing computation, which I like a little bit more. Doing mathematics or technology doing the maths sounds a little bit rough, I think, but outsourcing computation, I think I'm a little bit more okay with that one. Outsourcing gives me the sense that I am just handing this off to something else. And when you outsource, there is a reason for it. It's because the outsourcing is efficient, but it gives you back some resource, it gives you back some time, or it gives you back some focus on something else that you can do. Okay, so if the computation is being handled by something else, then we've got to have to hope that something valuable is being replaced by that, that there is some other type of mathematical learning that can be done with that time. Okay, and so the generalizing and the higher levels of mathematical work that we want to think about there can actually be attended to when we take our focus off computation a little bit. But I think that learning to compute has its values too. And a lot of researchers will say that hands-on calculations still, they develop some fluency, they develop some concepts that are going to pay off further down the track about perhaps how algebra works and things like that, that if you hadn't done some computation, you're going to miss out on this. So I'm not saying that we should hand off all computation to technology, but I think we should be aware that we can, and if we can, then we should be doing something good with what's left behind, I suppose. So there is no firm guidance, and I don't think it's going to be an easy thing for researchers to figure out, because it really matters on what your goals are. If your goals are to complete exams really well, and those exams require you to do calculations and show calculations, then of course we're going to not pay too much attention to tech. If your goals become problem solving, doing really messy, hard problems as an output of our learners, then maybe bringing in the tech is going to pay off with it. So it'll be interesting to see how curriculum changes and industry changes, I guess, might affect that type of question. I'm going to talk about 3 tools today. The first one is digital curriculum resources. We're going to talk about computer algebra systems, and we're going to talk about dynamic geometry environments. They give us a pretty good round on some things. So DCRs, digital curriculum resources, I conceive of them as a modern textbook. Okay, they're the place that students or teachers can go to find content and find things to practice. I'm sure the majority of you are using them or know about them in some way. They're things like Mathletics, Manga High, Maths Buddy, Education Perfect. We have a whole host of them that are available in New Zealand, and in other countries they have some slightly different ones too. They are not just those things. It's a little bit more scope to that, but let's just leave it at that for now. So they are places that students can go and they can get access to content, and they can get access to practicing stuff. In the research, they tend to say that there are 4 parts to a DCR, that there is a presentation space where the students have the ability to learn some content or engage with some content in some way. These might be videos, they might be slide types of systems, those kind of things. There is normally a problem space, which is where they can do their practice. So if we're looking at our diagram up to the right there, that is the point 2 on that one. Some of them have a workspace. This is an area where the students can do some of the mathematical work. Others just have a place to input an answer. And then there is a navigation space, which is about the student or the teacher accessing the things that they need to, menu systems or delivery systems for what needs to be done. So that's just a little bit about what these things are and how in literature they conceive of them a little bit. But I think many of us understand that there are benefits and drawbacks of these things. So I thought I might just put it out to you guys to go to this Jamboard, which I'm going to put in the chat in a second, and just put a little sticky note on. So there's 2 slides. You can navigate along the top to the 2 slides, and just put a little sticky note about what you think a benefit of a DCR is and what you think a drawback of it might be. So let me just pop that into the chat now. Okay, so if you follow that link, we'll try to make it sort of 3 to 5 minutes of doing that. So just on the left side of the screen, fourth icon down is a sticky note. Pop that on the screen. You can change your color. You can change the angle. And then, yeah, right in the top middle of the screen, there is a little slide. It says 1 of 2. Actually, it says 1 of 3 because I've just got a final one for any other thoughts later on. And you can write down what your drawbacks of a DCR. So what are the issues, problems that we might have with using a DCR? So we'll just take 2 more minutes on this. You can please try to get onto the second slide across and write down what you think some of the issues with using a DCR would be. Cool, so I'm coming onto that one now, that's great. Okay, so we'll start getting ready to come back to the main presentation. Thank you for your engagement in that. There's some interesting comments there. A lot of them would be what come to mind for me too. And maybe in reading other people's, found some resonance there. Okay, so just a couple of things to think about when using a DCR. This word outsourcing. Am I actually outsourcing my teaching when I use one of these? It depends on the one that you're using. Some of them will have content parts to them, and some of them will really just be places for kids to practice. And a lot of people mentioned on those Jamboards the instant feedback, so they can see if they're getting stuff right. So I think we do need to be a bit wary of that if you're using them that way. Sometimes it seems the best thing to do. We teach a lot of mixed ability students, and sometimes we do have to outsource our teaching to these DCRs and say, well, I need to focus on this group today and teach them, like live teach them. Whereas there are a group of extended students that I can just feed off some extra work to do. Okay, and I probably used to do that with textbooks anyway, because I would say, hey, you guys, you already know the stuff that I'm going to teach most of the class. So why don't you read these pages and do these problems? So yeah, that's just something to think about there. I just have this little issue that I think that when they see, Khan Academy is a good example of this too. When they see that maths is all lined up and ready for them to go, and it's just there, maybe they see themselves as just a consumer of maths. That this is just some stuff that I have to do. It's already been produced. My thinking and my background is not important. There's no way that the technology is going to appreciate me. I am just a consumer of this stuff. So then we just need to be a little bit wary about what view of mathematics they're going to get when we use DCRs, if we use them too much, perhaps. People mention instant feedback, which has its benefits, but I think we also need to think about feedback quality. If we're leaving DCRs to do all our feedback, then are they really getting quality feedback? Right and wrongness is okay, but there is better quality feedback that we can be doing. Yeah, it's something to think about. When I'm not saying you shouldn't use them. In many ways, they're great. I'm just saying that when you use them, think about some of their drawbacks and think about how your teaching in the classroom can sort of supplement what the DCR is not doing, or what it might be actually harming a little bit, perhaps. Okay. So the next one is computer algebra systems. All right. So for me, I can see this as a very fancy calculator. So it is something that can do mathematics, and it can do mathematics with things that aren't numbers. All right. So it can do algebra. It can work out matrices, equations. It can do all sorts of things. We can turn that into a learning situation if students just use it as like a knowledgeable checker. So they do some maths from a textbook or from the board or whatever it is, and they're using their computer-aided system to check them or check steps along the way or something like that. Obviously, that requires a little bit of teaching about what the best way to figure out where you're going wrong is and how technology can help you with that. But it could be used that way. But I also think that concepts can be developed when you're using a CAS, if you structure the task right. Before we get onto that type of thing, I would like you to go to GeoGebra. So GeoGebra, if you go to its main site, you have to click on Start Calculator or something like that. If you put the calculator part on the end of it, it will take you to basically what you see in Desmos as well, a screen that you can enter inputs, and it's got a graph and things like that. When you get there, there is a little drop down, and if you drop it down to CAS, then you'll be in the computer algebraic system version of GeoGebra. Go there, just type in something like this. So this is expanding and simplifying two brackets is what we might be doing. Type it in, see what it gives you. And I will pause for a minute or so, and I'll talk about what else we could do with something like this. Don't remember exactly what I had on the slide, but this. Okay, so it actually took a little bit of time there. Firstly, it has graphed it. That's not what I'm interested. I'm interested in what the output was. So it has simplified this whole expression into 7x plus 25. I might hide my graph because it's distracting as much as anything. On the slide back, and I'll come back to it soon, I talk about a task structure for doing something like this. There is a lot of research about using computer algebra systems, and there is also within that a bit of research about using pen and paper alongside of it. And one of the task structures that they suggest is that you have you get them to do some maths, you get them to check it using the algebra system, and then you get them to reconcile and fix up and find out what's not going right for them. So what I might do with this one is I might actively teach direct instruction, that first type of problem on the board. But when you're teaching something like this, I think anyone who's taught it will know that you get issues with a minus sign. We put a minus sign in front of that 5, and they get minus 5x plus 20 or something like that. So they forget to take that minus sign through the whole way. So in the past, I might have had to really address those kinds of misconceptions in my direct instruction. And there might be other ones. So I might have fractions in there. I might have negatives in different places. I might have letters on the outside of the brackets as well. So there could be a whole bunch of different types of examples that I would have to go through. And my students will be bored of me in no time. This presentation might be bored of my voice already. So what I'm saying is that you could do a lot less direct instruction. And for me, that's important in my non-learning environment, because holding attention in a big open space is quite hard. So I could do less direct instruction, and I could set up a task where they start to find these anomalies themselves and trust that the computer is sort of right, and try to work backwards about, well, what do I have to think about here that's going wrong? Okay. Yeah, and then I can float around and quiz them on that type of stuff. So this is what I'm calling the predict, well, not what I'm calling, what Fonga calls the predict, act, reflect, reconcile model. So a small amount of upfront teaching, then you have a worksheet where they predict the answers to all of these. Okay, they do their best to get the right answer. They then act with the technology. They put it into the to GeoGebra in this case. They then check, or reflect is the word that she uses, and then they reconcile. They try to figure out, well, if I'm right, reconciling is easy. If I'm wrong, reconciling takes a lot more thinking. I have to go, well, what is it about this that meant I got the wrong answer? Okay, so go back to that GeoGebra screen you've got. We're going to just do a very quick investigation of x to the n minus 1. All right, that we're not going to use the letter n, we're going to use some numbers in place of the n. All right, so you might want to start off with something like x to the power of 8 minus 1. Have a play with that. Yeah, have a play, and then I'll show you some stuff on screen too. Oh, sorry, I didn't tell you how to factorize. Just typing it in won't do anything. If you type in the word factor, brackets, and then the thing that you want to factorize, and you can use this panel down the bottom for your powers, or you can use that hat key, shift 6 on your keyboard for that. And it will factorize it for you. So I haven't taught a lot of calc in the last few years. I'm not sure if we've got some calc teachers here that would know how to factorize something like that. Another one, I'll do x to the power of 7. My factor in front. Okay, so yep, that factorizes. Quite a different factorization to the last one. Although maybe I'm noticing that there's something similar, that I've got x minus 1 for both of them so far. So my interest is piqued. I'll go 9, shall I? Okay, it's got x minus 1 again. All right, so I'm developing a conjecture, I think. I think that anything of the form x to the power of n minus 1 is going to have x minus 1 as one of its factors. Okay, and this approach isn't going to prove that to me, but it's going to give me some evidence to make that conjecture. And I hope what it does, and they suggest in research that this does often happen, is that they do move on to trying to use, I guess, more formal methods for proving this kind of thing. I think what I noticed from this one is that there is some other patterns. So I'm interested in this x to the 7 was x minus 1, and then it had this series of x to the 6 all the way down to x to the 0. It's a prime number, 7. Is that the reason for that? Try another prime number. Okay. Initially, I might have thought it was odd numbers that did that, but I see that x to the 9 somehow did split into a different amount. Try another one, x to the 12, shall we? Okay, so that's quite a weird one. It's got a lot of different factors. Maybe with my even ones, I want to focus on something else, that these particular factors that go in the sequence of powers, x to the 0, x to the 1, x to the 2. See that there as well. I don't see it up in this one, x to the 8. X to the 8 is an interesting one. I wonder if x to the 16 would have any properties that I could notice. Okay, so it's got an x to the 8 plus 1 at the end. That had x to the power of 4 plus 1 at the end. So there are a whole bunch of patterns that I could start conjecturing about, and I hope that my students would be wanting to go, well, why is that? Well, I think I've identified a pattern, I've got a conjecture here, but why is it like that? So some pretty conceptual stuff can be handled when you use a CAS as well. It doesn't just have to be practicing skills or doing mathematics. If you approach them the right way with the right type of task, then they can be doing this high power computation stuff on a computer, but still doing really good mathematics themselves. Okay, so that's that one. This time than I thought. My favorite one is dynamic geometry environments, DGEs. Okay, so these GeoGebra is my favorite. Desmos kind of fits into this, although it doesn't do the geometry. Well, to my knowledge, it doesn't do the geometry as well as GeoGebra does. And then there's Geometra's Sketchpad, used to be an older one that people don't seem to be using. GeoGebra is free, online, easy to use. It's a good go-to. If you're using these, you can just use them on the screen. You can get them, you can send one to them, and they can drag some points around that are already made. So that's quite good. It can help explain some concepts in a nice visual way. But I think the true strength of what we should be doing with this would be to use its dynamic nature, and to get them to start being part of designing these dynamic diagrams that can be made. So we can talk about variance and invariance. When stuff moves on the screen, that's variance. Sometimes other stuff won't move, or it will move in relation to the thing that you're moving, or the number that you're looking at, angle size or whatever, is staying constant the whole time perhaps. So the idea of variance and invariance can be seen on the screen. They say that students start to internalize what they see on the screen. So you can look at a geometry problem and start to go, well, in my head, if I'm dragging that point around, what's actually changing about this problem? So there's been research on that. And I think when I think about myself, I do that. I see problems these days, and my go-to isn't always the formal maths. I start to go, well, if that thing there changed a little bit, how would it affect the other bits? So that's just a personal version of that. I guess the long-term thing that we would be wanting, and you can't get there straight away, is that the students become creators with GeoGebra, that they can make things that help them solve problems themselves. They're not just engaging with pre-made ones that you, the teacher, has given them or found for them, however it's been sourced. So we're going to come back to this problem that I put as our starter. It's an interesting one. It doesn't look like there's enough information there. That's with a lot of our problems. It's just like, well, is it even possible? Because that could be quite a different setup if I rotated that square around a little bit. Maybe the area would be bigger or smaller. I don't know. So I am going to put 3 links in the chat at sort of different levels of user, I suppose. Excuse my emails. So if you're a reasonable user of GeoGebra, click on the first link. If you're pretty new to it, click on the second. If you really just want a finished product in your hand, click on the third. Where is it? Okay, so top link is very little setup has been done for you. Middle link, most of it's been done for you. Third link, all been done for you. I'll click on the second link so you kind of know what you're trying to make. Hopefully that's not in your way either. So the idea is I've got 3 points set up. A and B, I've put exactly 6 units apart, just like the problem said. What you might notice is that I've reorientated this. That 6 was on an angle before. Now I've got it flat just because it's easier to make it that way. So those are there, but C can move around. And when I move C around, it reconstructs the squares based on that. Okay, so it's not that hard to do. There is a tool in here. There's a polygon tool, but there's also a regular polygon. Square is, I want to make a square nice and easy, so I'm going to use the regular polygon. And what you do, I'll just do it over the top of this one, is you click on the two points that are going to be your side. You say, I want 4 vertices, and it will draw it. If that happened to you, happened to me the first time as well, it's drawn it in the direction I didn't want to. So I'll just undo that. Delete it. And I'll do it in the other order. I'll go from B to C instead. Okay, now it's drawing me the square in the right place. So these are the little user technique things that I'm saying that you do need to develop when kids are using tools. That can be a little bit frustrating at times when the tool doesn't quite do what they expect, but this is part of the learning, I guess. Okay, so how does this help me solve that problem that Katrina had posted? At the moment, I've been able to sort of set up the system, but I haven't got that pink area from before. So I'll pop that on. This is a non-regular polygon. I'll just connect these points up. Okay, so that is a slightly rotated version of the problem that was given. Okay, those are connected on sort of a hinge there, and they're 6-part, those ones. So have I found out anything here? Well, if you've got your left-hand panel up, you might be able to see some stuff, but I'll do it in a different way. So I'm going to get the settings up, spin behind this, and I'm going to change the label to the value. So it's going to tell me this little number that's popped. This little number that's popped up here is saying that my polygon is 18. And what it means by that is that the area of my polygon is 18. All right, so that's nice, but I'm pretty sure that when I move it around, that number is going to change. Okay, and it doesn't change. All right, so there's something about this problem that means no matter how far I distort this shape, this red shape, that the area inside it is still 18. Okay, so that's a technological answer. But what I want to do as a proper maths teacher, I suppose, and what I hope my students want to do is go, well, why is that? Why doesn't it change? What can I see in this problem now that I couldn't see before? And I don't have enough time to really go through that, but you could block out what a 6x3 square looks like and think about how these two areas might be the same, and yeah, I'll leave it at that. Okay, so I'll very quickly try to finish because we are supposed to be done pretty much. So in conclusion, tech is good at some stuff, and we should let students know that and let them have some facility with that, but we can't let it take over. It could take over some of the calculation, the computation stuff, and that for me would be okay. You might have different views on that, I'm not sure. We can still use tech to help kids practice. The immediate feedback that people are talking about is one option for that, but they can also use the tool to help them check. And I believe in this idea of getting the tools into the students' hands at a low level and then evolving to become good users of the tools, so that even beyond school, they start to think about using these things to understand and problem solve and create in the future. So it really comes down to, I think, the way you use tech and what your goals are. If you have goals of a certain thing, then you use tech in a certain way. Sometimes you don't, though. Sometimes you just go with the easiest and you're not so thoughtful in the way you use tech. I'm very guilty of that. So do try to think when you're taking on tech or when you're not taking on tech, think about what your goals are, and hopefully you can make some good decisions about that. So I better show my reference slide just because that's the thing you do. Otherwise, that's me. I haven't really left any time for questions. If you do want to post any in the chat, I'll do my best. Or on that Jamboard that you were on before, the final slide on that, you could just post a sticky note into that and ask me some questions. So thank you for your time.
Thank you, Jared. Back to me again, Alan. I'll just have to do my duty to thank Jared and put a little bit of what I've learned from here. For me, it made me rethink my use of technology, and probably for most of you as well, as it provides opportunity for my students to, as Jared has mentioned, do math, learn math, and develop concepts. I put here some of the things that technology provides us. I think provides us with some feedback. If you use some, say we've been in Education Perfect, and I love Education Perfect because if I'm away, I just have to design some activity from Education Perfect and also as an activity for the kids. I think I like the part where you presented the GeoGebra, where the students would have the chance to explore and go into mathematical investigation. There are so many more things to say. Probably some of you, some of the participants may want to comment as well. But at this point, I'd like to thank Jared. Thank you very much for the opportunity to learn from you and with you.